Morning.
Good deal. Let's make sure we got this rolling. I just had to restart my whole computer because it was not wanting to play along this morning. It was like, no, I'm not playing. Thank you. It wouldn't start Zoom. Now we're rolling and we're fine.
Guys. How's your week? Pretty good.
You ready for a nice spring break, everyone?
Yes.
You have 2 weeks off, right? Everybody knows? Yeah.
I think I have an entire. So after this, is next 2 weeks is leave?
You have 2 weeks off. Yep.
Thank
We have, I try to do, so just so you guys know for future reference, because it's pretty much the same pattern always. So I try to do spring break whenever the county does spring break. I try to. It doesn't always work out. But I try to do spring break whenever the county does spring break, because people that do activities, like their schedules tend to change. Because if everybody's out of school, like if you have practice in the afternoon, they tend to move practice to the day, like a sports practice or whatever. So I try to do that. And then whatever week is Holy Week, so in between Palm Sunday and Easter, I always have no class that week because I'm too busy. I'm way too busy because I'm at church like Thursday, Friday, Saturday, and Sunday.
RDOs
So
has
just
spring
too
break
much.
2 weeks from now.
There you go.
So
Yeah.
I get that entire week off.
There you go. Yeah, it's just too much for me to try and do anything during Holy Week aside from Holy Week.
I've been having.
I think everybody in here missed the My Instrument question.
That was the piano. It was the voice,
I thought it was
vocal cord.
Yeah,
There you go.
Yeah,
I just got to guess piano.
because the piano's in the house, so that's an easy one to guess. And somebody picked clarinet, which is also smart because I did for a couple of years play that, and that's what I sing.
I studied.
My instruments, my chords. Remember in the video, I showed you a picture of my actual chords. It was gross. I figured that's a way to know if they actually paid attention to that whole video, because that's a.
I don't know what I put. I think I put larynx or.
Yeah, I think there were, aside from Drew, there were only like 4 people in the whole class that got it right.
Wasn't that the week that you got strep?
Yes, I had strep that week.
My brother said a human voice.
Yeah, he got it. He was one of the ones that got it.
It's
yeah.
kind of funny that your music,
Mhm.
your music wasn't working that week.
Yeah, it is interesting. Yeah. Yeah, my instrument, I've only ever seen it the one time when I went to that doctor and he stuck that camera down my throat and went, there it is. And she did. And I was like, oh my gosh, I've never seen it before. I've been using it my whole life. I've never seen it. Yep. That was pretty fun. Weird, but fun. So that's why I'm so busy all of Holy Week, because, well, I usually sing Wednesday night too. So I sing Wednesday night, I sing Thursday night, I sing Friday in the middle of the day, I sing Saturday night, and then I sing twice on Sunday morning. So I'm very busy the Holy Week. On Friday, on Good Friday, we do at church, we do the Passion, right? But we sing it, we chant it, we don't just read it, we chant it. And I always do the narrator part. So that's the biggest part. So it's me and 2 other people, one who chants all the Jesus lines, all the quotes, and somebody else who chants anybody else that has a part in the story. But the whole narrator part, like the whole storyline's me. So it's about 17 minutes of straight singing on Friday. So yeah, I don't work that week because I'm doing my other job. Yeah, it's a lot. Actually, it's on the piano. If you ever wonder what 17 minutes of straight Anglican chant looks like, it's sitting on. Look at good, Lewis.
I got it.
All right, gang. So you guys probably saw my email that everybody's grade got curved. I want to send a friendly reminder that extra credit is always an option. You can always give me extra credit for any test, but it's due the day of the test. So what you need to do if you want to get any extra credit for that test is you're going to need to look at your preface, and it tells you that you can go to like the chapter summary or chapter review. Get any questions. You can give me up to 5 and you can throw them in that folder before you leave. Or I'll tell you guys this, if you get them to me by like 5 p.m. today, I can probably still count them because I won't start I'm going to start cranking out progress reports tonight. And I'll probably start doing that around like 6 o'clock because I got to drive out to Marietta for gymnastics carpool. And then I'm going to get myself some dinner and sit myself down and start cranking them out. So if I get any extra credit, and that will be thrown onto the curved grade. So if you get an extra 3, 4, 5 points, I can throw it onto the curve grade, okay? That would help everybody a lot, so I highly recommend that. Okie doke, are we ready to roll? We're Q4, so we were just saying, Darcy and Lewis, that we got 2 weeks off, right? After this, 2 weeks off.
So we got new lab teams,
Yes, you have new lab teams,
but I'm still James and Lewis.
but you guys know, you
Yeah.
should, everybody knows their lab teams, right?
Yeah, I know.
Okay, you know your new lab teams. And today, if we finish early, I'm gonna let everybody go out and have an opportunity to look at the plots. The plots have been plotted in the back, but I haven't run. So what we did is we put the 4 pegs in the boundaries, and then we tied the colored tape on the 4 pegs. When we actually start building, I'm gonna like rope off the whole thing with tape, but I don't want my neighbors to look at that for like 2 months. 3 more classes? Yeah.
Have you been to Bitzel's Chocolate Factory?
No, where's that?
Swanee, oh my gosh. It's literally
Downtown Swanee?
Yes.
Near
Town center?
Near
Okay.
Main
I'm sorry.
Event.
Okay, now I'm going. Thank you for
It's
telling me.
literally the best.
For sure going.
Last chocolate factory. Remember that, seeing that on the Fox 5 News, isn't it like
We've been
glass chocolate factory?
literally best place ever.
I'm for sure going then.
Right.
Yeah.
All right,
I remember
so-
that place on the news.
So I recommend everybody try and toss in some extra credit. Remember that I never give above 105%. So even if you have the highest grade in the class, even if you're the one that got the 100%, you can still add on to that, but you can't get above what would be 105%, okay? Because that's like ridiculous to get above that. All right, so there's that, and then 2 weeks off, and then new lab teams, yes.
I don't think you send the grades to my email.
It's been
Yes, that's
completed and
what it
returned.
is.
Yeah, whatever email is in Teacher Ease is where everything goes. Like I don't send it out separately. I send it through the app. So if you need it changed, you can go in and change it yourself, or you can ask me to do it and like tell me what you want specifically, like write it down and I can do it. All right, so we are in Q4, which is our light touch on chem before we begin chem full on next year. So we have our periodic table up to dawn. Fancy, right? Very nice. This is a good one. It's a nice size. It's durable. I take it down and put it up every week. Way to go, homeschool chemistry. All right, so are we ready? We're gonna play a game today too, so pay real close attention to all these definitions. They're gonna come back at you. All right, so each specific substance has its own combination of what that can be used to Emma. Properties is right, that can be used to identify the substance. So what do we call the building blocks of matter, Darcy?
Element.
Elements. So the building blocks of matter, because all matter is composed of elements. Okay, an element. These are elements right over here on the periodic table. An element is the simplest form of any substance, meaning that once you have that substance in element form, you can't break it down any further and have it maintain its properties. So for example, water. What's water made of? What 2 elements are in water?
Oxygen and
Yeah, and oxygen.
hydrogen.
Yeah, 1 oxygen and 2 hydrogens, H2O. Okay, so you can break H2O down into H and O. So you can break it down into hydrogen and oxygen. But if you break oxygen down any further, you're just going to get subatomic particles. So you're going to get protons, neutrons, electrons. Same thing for hydrogen, right? Except you're not going to get what in hydrogen? Does anybody know? It's missing a neutron. This is so light, so low. So yeah, so that's what you're gonna end up with. All right, you gonna do the next one for me?
Sure, it's an atom.
An atom. Today, scientists use the word atom for the smallest particle of any element. Okay, it's not always been the case. And there was plenty of time in history, we'll talk about it more next week and a little bit this week, where we thought atoms were the smallest thing we could possibly have. And now we know better. We know there are particles within atoms, and then there are even smaller particles besides protons, neutrons, and electrons. There's all kinds of stuff going on. All right, so what kind of changes are the 2 ways that matter can change? All right, Eunice?
Physical changes and chemical changes.
Physical changes and chemical changes. So what do you think these represent? Which one of these represents a physical change and which one represents a chemical change? Emma? What do you think?
The fire represents the chemical change. and
Yes.
The melting represents.
Yes, a physical change, right? So fire, although something's getting hot and the heat can cause something to melt, fire itself is a chemical change because combustion is going on. All right, so unlike its weight in objects, Lewis,
Mass.
that's right, an object's mass will not change if the force of gravity on it changes. So what is gravity? What's the definition of gravity?
Do
we remember?
Force that pulls us towards an object.
Right, and then
Another object.
what is, so right, so what's weight? Who remembers what?
Weight is the amount of gravity measured
The effect of gravity on
the planet Earth, the object.
any mass. Okay, so weight is the effect of gravity on any mass. Gravity is the force that's pulling us all to the center of the earth. Remember, gravity is an attractive force between any two masses. So gravity is pulling me down to earth, but it's also pulling earth towards the sun and the moon towards the earth and other things within the universe towards each other, right? There's gravity everywhere. Do you remember the video of the man with the stretchy neoprene fabric over that big
The
hoop?
Lycra.
Yeah, the Lycra, right? That's right, Lycra. And he sent those marbles out and watched them roll. And remember, they would come together. Two of them would
Yeah.
come together and you could see that bend. And that's that whole really cool space-time bending stuff. That's good. That's when you get into all kinds of mechanics and physics. That's really fascinating. So if you love physics and math, do that stuff.
Okay.
Learn that stuff in college. Yeah, it's cool.
I love math.
It's very cool. And by the way, speaking of physics and math, did anybody watch the launch this week? The SpaceX launch? Yeah,
Oh, I
SpaceX
saw
launched their third Starship launched
Heard
this
of
week. I think they had the booster, I think, crashed on the way back down, or didn't. They were trying to land the booster, on the water, and they do that and the little floaty barge thing. But it had some of the best and clearest camera angles I've ever seen on any launch, and it gave perspective from the ship and perspective from the booster, which we've never seen. So if you can go look it up because it was just this week. But I'll also tell you, amazingly, that Starship, the SpaceX where they launched from was in Texas. And so Cole had just done spring break, literally right across the water from there. And so Jason was like, man, if you were staying 3 more days, you could see the launch. Of course, he had to go back to class, but he went down there and took a picture, and he's right in front of the rocket. You can get it's crazy how close you can get. It's a 40-story building, so it's in the distance, but it looks like he's close enough to see it. Clearly, there's no gate. He's just on the side of the road going, hey, there's a big rocket behind him. And Jason was like, oh my gosh, I'm jealous. So it was impressive how close you could get. All right, concepts here. Let's talk about this one. What is mass divided by volume? What is that? What does that give you, Lewis?
Matter.
No matter. Mass divided by volume gives you density, everybody says. Yes, density. All right, so looky here. We're going to actually build one of these next year in chemistry in a demo lab. It's a lot of fun. This is called a density column.
They're like the oil,
Yeah, they're different liquids
but
with,
they don't mix into.
yeah, they don't mix, and they're
I
different.
tried making one of those.
They're different liquids with
I
different
took a
densities.
picture when I-
So the one that I do in chemistry, the density column I do it in a big, tall graduated cylinder, and I do it with sugar solution. So it's only sucrose and water, but it's there's the super saturated one, and that's going to go to the bottom. And then I do them in a rainbow color. So it goes a spectrum, basically you get your Roy G. Biv going on, right? But each one of them is 10% less saturated than the one before it. So I have 90% sucrose, 80, 70, 60, 50, 40, and we pour them in, and it makes a rainbow column inside a graduated cylinder. And as long as you don't shake it, they don't mix, and it's really cool. So who is it that imagined atoms to be like tiny marbles or rigid spheres? Darcy? Dalton. Okay, John Dalton. We'll talk about him a little bit more next week, but yes, Dalton did this. He thought they were rigid spheres and they're impossible to break. Was he right or wrong? He was wrong. He didn't know, but he had the idea that they're tiny. Yep. But we know now that you can break them apart. All right. By the way, what's it called if you split the nucleus of an atom? Do you know what it's called? Anybody know? Not the next question, but does anybody know what it's called if you split the nucleus of an atom? It's nuclear fission. If you combine, you get nuclear fusion. But if you split the nucleus of an atom, it's nuclear fission. Do you know what happens? You ever seen pictures of Hiroshima, Nagasaki? That's what happens, right? Yeah, it's a kaboom, right?
They had 7 extras, and they were like,
Mm-hmm.
"Who's going on?"
Who knows the name of the plane that flew that bomb?
Oh,
Do you know it?
A bomb.
Yeah, the atomic bomb. Enola Gay. It was named for his mom, I believe. Enola Gay. Yep. All right. So gold can be separated from other materials in a mixture because of its Darcy.
Density.
Its density. Okay. Who's been gold panning before? Anybody ever been? You been? In your backyard? Did you get any?
Like a speck, I think. You were obsessed with watching gold.
Oh,
Oh,
oh.
I did it in my old school.
You got
like,
pyrite. Yeah. So if you enjoy minerals, crystals, if you think they're fun, if you think they're pretty, I highly recommend taking a day trip. Yes, go to the Dahlonega Consolidated Mines, which is quite literally beneath a Walmart in a Walmart parking lot in Dahlonega.
What?
But yeah, Dahlonega exists because it's a gold town. It's a gold rush town. So they found gold, and usually you'll find gold inside quartz veins. So quartz veins contain gold, and they found, now they put a Walmart on top. So yeah, under the Walmart,
You got
but there wasn't a Walmart at the
down
time.
there, you know where it came from.
There you go. Oh, that's Cleveland, but yeah, you're right. So yeah, if you go there, you can take a tour of the mine. They'll take you down into the mine, and you can see where they've taken out all the gold, right? But also you can do panning. So they have a sluice. So a sluice is like a big long
Or when
Yeah,
you're not looking
like
at
a
show.
tray. It's got water running through it. And-
we did like jewel, and I have this really big.
I still have all my
I have a
my
really
gosh,
big
minerals,
amethyst.
too.
chunk.
Yeah.
I did it when I was a
Mhm.
I
kid.
should bring it. Oh, do I still have it out?
So what you do, the way you pan for gold, okay, so hold on. So listen, so the way you pan for gold is cool. They give you a shallow, it's almost like a pie pan, right? It's like a shallow dish. Yeah, literal pan, and you put sand in it, and you put it under the water's running, okay, it's running
Yeah.
water, and you
The-
dip it under and lift it up. And when you dip it under, everything that is less dense than what's, like the least dense particles in your pan will come to the surface and wash away, right? And then you do it again, and you do it again, and you keep doing it. Every time you do it, the more dense particles are gonna stay in the pan, the less dense particles kind of poof up and they get washed away. So you can do it in a stream.
I
too.
actually had this huge thing of tiger's eye.
Oh, yeah?
And loads of rose quartz from when I did it when I was like.
I'm
first
still
grade.
missing my daddy's tiger's eye ring that I had out with One-Eyed Wilhelm at Halloween. It never came back. I don't know where it went, but it disappeared. If anybody finds it anywhere, let me know, because that was my daddy. So anyway,
Have you ever gone to the what's that place?
there was a mood ring too, but that came back. There's what?
Where's that place in Tennessee with the big trucks outside?
Oh, I don't know.
It's a museum.
Oh,
A planetarium.
I don't know.
I forget what it's called.
Sounds
but it
cool.
also has-
Gosh, I haven't been.
So anyway, if you pan for gold and you dip your pan enough times, the only things that are gonna remain in the bottom are the heaviest and the densest of all, which is the gold. Gold's very dense.
Yeah.
So then you can pull it out, and if you do it there, they'll give you like it looks like a little test tube as plastic, and they'll put your gold in there with some water, and you can like shake it around and look at it. It's really kind of fun.
There's
All
like
right,
a
so to obtain an element from a compound, what has to happen, Eunice?
chemical reaction.
A chemical reaction has to take place. If you take an ice cube and you just let it melt on the counter, there's a physical change that took place, but no chemical change. You still have water. But if you want to get the hydrogen and the oxygen apart, which we will do in chemistry next year, we will take water and we will turn it into hydrogen and oxygen. And it's really fun.
Can I eat? No, okay, can I eat hydrogen?
No, but the cool thing is what happens with oxygen in the presence, what happens to fire, I guess I should say, in the presence of oxygen? Do we know what?
It grows, and when
Yeah.
there's no oxygen, it fizzles out.
Right, so oxygen is food for fire. So when you cover fire with like fire extinguisher foam or powder or a
Or
towel,
glass.
basically what you're doing is you're smothering the oxygen, and
Yeah.
so combustion requires oxygen. So the way that you know, because we're gonna have 2 test tubes next year, and one will be filled with hydrogen, the other will be filled with oxygen. And the way you know is you take a match.
It'll be filled with hydrogen.
Yeah, one with hydrogen and one with oxygen. You take a match actually, and then you blow it out so that it's still glowing red, but it's not burning.
Yeah, I've done that with like
You wave it over the top of that test tube that has oxygen, and it goes pop, and it makes this loud noise and a flash sometimes. It's really cool.
Do we
Mhm.
get Bunsen burners?
We will have Bunsen burners next. You'll have Bunsen burners in a couple weeks. Yeah, we have Bunsen burners. We do Bunsen burners. All right, so because the particles in what are packed tightly together and stay in fixed positions, it has a constant, definite shape and volume. Emma,
A solid.
Right, a solid. Okay, so this is what a solid looks like if you represent it as molecules tightly packed. This solid in particular, shh, guys, this solid in particular, I can tell you this is a crystalline solid because they're organized so perfectly. So this is like what you might see inside of a quartz rock or something, a crystal like that, a crystalline solid. So because the particles are free to move, what has no definite shape, but it does have a definite volume? All right, Nico.
Liquid.
A liquid has a no definite shape, but it does have a definite volume. So if you pour a liquid into a glass and then you pour the same volume of it into a graduated cylinder and you pour the same volume of it into a, I don't know, a flower vase, you'll find that it takes whatever the shape of its container is, but it's not going to change its volume. Now, can you change the volume of a liquid?
Yeah.
Yeah. What are some ways you can do that?
Evaporation.
Drink it.
It's well, a couple ways you can change the volume of a liquid. You can heat it, and that will cause it to expand to a certain degree. But if you heat it to its boiling point, now you're going to start having a physical change, a phase change, right? You can also cool it, and it will shrink, except for what? We have one liquid on this planet that is familiar to you all. That
Water.
will, yes, that will expand when it gets right to its freezing point. So here's the weird thing about water. Water will continue to decrease in volume as it gets colder and colder and colder. And then right when it gets to its freezing point, it will expand. You ever put anything in the freezer? Yeah, Coke. That's it. Kaboom.
I accidentally
Right?
put Coke in the freezer because it
Oh.
was like warm but hard, and I wanted to make it cold.
Yeah.
And, I forgot about it.
Yep.
And then next thing I knew, there was like.
You had a heck of a task of cleaning up, didn't you?
Our refrigerator in our garage
Mm-hmm.
freezes.
Yeah, sometimes
And
happens.
all our sodas, like we,
Exploded.
yeah, like all our.
Garage fridges are famous for that. I used to have a back porch fridge at my last house, with a screen porch, and that was bad. So let me tell you why it's particularly important that water does this. So water will expand upon freezing, and it forms a crystalline type of structure, which is why we get ice, right? And the reason that's important is because suddenly now it's less dense than it was in its liquid form. And the reason that's important is because if that didn't happen, there would be no life on this planet, or very little life on this planet. I want you to think about a pond. Hang on a second, put your hands down for a second. Think about a pond in the winter. Okay, do fish live in some ponds?
Yeah.
Yeah, okay.
Yeah, they
Do they survive winters?
Yeah.
Yeah, most of them do survive the winter.
Oh, have you seen those like
So-
those fish that are like under the ice and then like
Yeah.
the ice has.
People go ice fishing, right? You cut a hole in it and then you pull the fish out. All right, so why don't the fish freeze to death in the winter?
Those ice floating.
The ice at the top, very good. So when the ice is at the top, because now it's less dense when it's frozen.
Yeah, you.
When that ice is at the top, those fish can continue to live underneath. Now they are ectotherms, so they're cold-blooded, which means they can endure some pretty cold temperatures.
Right.
But if ice was less, if ice became more dense when it froze and it sunk to the bottom and continued to build up to the top,
They couldn't live.
nothing would live. Right. So it's very important. All right. So what's the last one here?
Danny.
All right. What you get for me and Lewis?
Gas.
Gases. Okay, gases spread apart, filling all the space available to them. Thus, a gas has neither definite volume or shape, I should say shape. So the other thing to remember, both liquids and gases, you can change their volume slightly by supercooling, superheating. Also pressure. You can change the volume of a gas under intense pressure. Same thing for liquid. This is how you get like spray cans that work and, you know, all that sort of stuff. You got gas under pressure.
Don't
Yeah.
you get cancer?
Are we gonna do the thing where like
CFC.
you put a beer in the
Mhm.
freezer just before it freezes, and then you knock at the bottom hard, and
And the
starts
top
to
comes off.
make- No, it starts like making all these little crystals.
Oh, okay. So that you can do that with water. And we're actually gonna do that next year too. Are you guys okay right there? So next year we're gonna do that too. If you super cool water, and it has to be like distilled water. It can't be water that has chemicals in it. It's
You're
gotta
making me
be.
wanna drink water.
Yeah, if you get water super cool, you can thump it and have it freeze inside the
Oh,
bottle.
I saw a
That's-
video of that today.
Because basically what you're doing is you have it right on the brink of freezing. It's right on the edge of freezing. And in order for it to freeze, all the crystals have to align, all the water molecules have to align and become crystals. So if you tap it, you agitate them to the point where some of them start to align, and then they all just align. It's like a chain reaction. Yeah.
I found an old bottle of water in the
Mhm.
back of my car, but I was super thirsty because I just ate so many chips.
Oh
And
gosh, okay.
it had cleaning spray in it. I
Ew.
didn't realize until there was like that much left. And I was like,
Mm.
oh, do I need to go to the hospital?
Yum, deliciousness. All right, so who found out that when the pressure of a gas is increased at a constant temperature, the volume of the gas decreases? And when the pressures decrease, the volume increases. Who is this, Emma?
Boyle.
This is Boyle. This is Robert Boyle. Okay, and we're gonna look at a little bio on him.
Is that how we came up with the word boiling?
Actually, no, but it's a great question. So here's Robert Boyle. A quick little biography on Robert Boyle.
Welcome to another exciting episode of
The funny voice.
Pioneers, where we explore the lives of individuals who have shaped the world through their groundbreaking discoveries. In today's episode, we turn our attention to Robert Boyle, a trailblazing scientist whose pioneering work laid the groundwork for modern chemistry. Robert Boyle was born on January 25th, 1627, in Lismore Castle, County Waterford, Ireland. He was the 14th child of the Earl of Cork, Richard Boyle, and his second
14.
wife, Catherine Fenton. Despite his privileged upbringing, Boyle was a curious and inquisitive child, displaying an early interest in the natural world. He received a solid education and had the opportunity to travel extensively across Europe, where he met and interacted with other brilliant minds of his time. Boyle is best known for his groundbreaking experiments and contributions to various fields of science, particularly chemistry and physics. His most famous work, The Skeptical Chymist, 1661, challenged the traditional alchemical beliefs of his era and laid the foundation for modern chemistry. In this work, Boyle introduced a concept that matter is composed of indivisible particles, an idea that foreshadowed the later development of the atomic theory. One of his most significant contributions was his formulation of Boyle's law, relationship between the pressure and volume of a gas at a constant temperature. This fundamental principle paved the way for the development of the gas laws and played a crucial role in the eventual establishment of the kinetic theory of gases. Boyle was a pioneer of the experimental method, emphasizing the importance of empirical evidence and systematic observation. His meticulous approach to scientific investigation and his commitment to accurate measurements set a standard for future generations of scientists. Robert Boyle's legacy is profound and far-reaching. His emphasis on rigorous experimentation and empirical observation laid the groundwork for the scientific method, which remains the cornerstone of modern scientific inquiry. His work not only transformed the field of chemistry, but also influenced diverse areas such as physics, medicine, and philosophy. In conclusion, Robert Boyle's life and work have left an indelible mark on the world of science. His relentless pursuit of knowledge, his innovative experiments, and his unwavering commitment to empirical evidence have earned him the rightful title of the father of modern chemistry. As we continue to build upon his legacy, let us remember the curiosity and dedication
Apparently.
that drove this remarkable scientist to shape our understanding of the natural world.
AI images and fingers don't.
Yeah, the AI images, they're fun.
And fingers and AI images don't go together.
Yeah, this is true.
Fingers are like the.
So who found that when the temperature of a gas is increased at a constant pressure, its volume increases? Who was that, Darcy?
It was Charles.
Charles. Okay. So when gas is decreased at a constant pressure, the volume decreases. So this means if something decreases when something else decreases, we have a directly proportional relationship. All right. Charles' law. This explains kind of how Charles's law works. Okay. This is kind of short.
You would have a cringy voice.
Not as cringy. Not as cringy.
Good day, learners. This is engineering. This time we're going to talk
He
about
just has an accent.
Charles' law.
Maybe.
In a gas, its physical behavior is described by these four variables, namely pressure, volume, temperature, and amount or mole. In this video, we will have Charles' law which is concerned in the relationship of volume and
Oh, boy.
temperature.
Oh, is
Charles'
it?
law was formulated by the famous scientist Jacques Charles less than 2 centuries after Boyle's law in 1800. This law describes how gases will expand when heated. In his experiment, he prepared a test tube with trapped air under a small mercury plug. It was immersed in water but with heating coil for heating and cooled with ice. Upon changing the temperature, the volume of the gas trapped in the test tube also changes. Having all the data, he then found out that volume and pressure follows this graph as shown. It can be seen in the graph that there is a dashed line portion because, theoretically, when gas reach absolute zero temperature or negative 273.50 degrees Celsius, the gas occupies zero volume. But no one has ever seen this phenomenon. The temperature unit is in Kelvin for SI unit or Rankine for English
We
unit.
can't reach Kelvin, right? It's
Derived
theoretical.
terms we have volume.
So I'll pause that one because I just wanted you guys to see the beginning of it, and it'll be linked, of course. But let's move on to this one. So this first graph, whose graph is this? Volume of a gas is directly proportional to its Kelvin temperature under constant pressure. Who's that one? Eunice?
Boyle?
That one's Boyle. I mean, Charles. Sorry, that one's Charles. Then the other one is Boyle, but so Boyle. So pressure temperature is Charles. Pressure volume is Boyle. Okay. Pressure temperature, Charles, pressure volume, Boyle. And we'll be talking a lot about that next year. Not as much this year. We're just touching on it, right? So thermal energy always flows from, what direction does thermal energy flow? What do you think? Eunice?
Warmer substance to a cooler.
Warmer to cooler. Yep, we know this because this was one of our, remember when we did our thermodynamics, touched on it real briefly right before Christmas. So a substance changes state when it's what increases or decreases? It's, Darcy?
Thermal energy.
It's thermal energy. All right, let's see if there's one in here for, oh, Carlos. We don't have any for you, Carlos. You don't have any coins yet, Carlos. No coins. What's a coin I can get? Okay, well maybe you can get one for this game. I'll give you one because you're gonna do the game. All right, so here's how the game's gonna work. We're gonna go to the back table and you're gonna have a few minutes to play, about 10 minutes. Okay, you're gonna divide into 2 teams of 3. All right, and what I have for you are a series of definitions. So it's terms and definitions, and these are all chemistry terms and definitions, all right? So here's how this works, so pay attention, because here are your rules. You're gonna divide into 2 teams, 3 and 3, you're gonna sit across from the table, all right? So team 1 is gonna have a bag of vocabulary words and definitions, okay? And then team 2 will have the matching definitions for the vocabulary words and the matching vocabulary words for the definitions, vice versa, right? So if team 1 has the word, team 2 has the definition. If team 2 has the word, team 1 has the definition, okay? So it's gonna be important that you kind of keep them on correct sides of the table. I'll explain. So you're gonna take a few minutes and organize. I'm gonna give each team a minute to kind of organize. Wait a minute, let's go through the directions first, okay? Because you may want to say, all right, these are all gas-related terms. These are all atom-related terms. These are all whatever, so that you can kind of organize a bit, all right? And I'm gonna give you about 3 minutes to organize, 4 minutes to organize. Team 1, this is how it works, is going to choose and read aloud 1 word or definition. And then team 2 is gonna have about 15 seconds to find the match. All right. And then if you succeed, you get to keep that set, that term and definition. It becomes your set. Okay. If you don't succeed, team 1 gets to keep the word and definition to ask it again later, but they don't get to keep the set. You only get to keep the set if you guess right, not if the other team guesses wrong.
If you have the most.
That's the idea.
Yeah.
So then team 2 goes, and then it just goes back and forth. So yes, question.
Is there a hot glue gun plugged in? It smells like hot glue.
It's because the heat's on, that's all. I don't even know what it is. So, do you have a question?
I found a brownie point in my book.
Oh, in the book?
In my body.
Jump.
Oh, I was gonna say, whoa, okay, write it down for me. So here's what we're gonna do it, let's come back here. Alright, so we're gonna pop out the chair. On each side, so there's one over there. Bring this guy around over here, whoops. So you're gonna wanna bring that other chair around that side.
On this side.
Again, so bring that chair, that's it.
Carlos,
Alright,
I'm sorry.
okay, so
They have a vanity.
here's how it works. Alright, so put up. Hang on a second, I'll come over yet. So here's the thing, here's the only thing I asked you to do. We're gonna use them again in the next class, so here's the important thing. If you get to keep, say these two go together. They clearly don't, because look, they don't fit. They actually fit if they go together. So if they go together and you get to keep it, I'm just gonna ask that you do it with, if this team had the definition, keep the definition over there. If this team had the term, keep it over here. Or if it was the other way, only because here's what I'm gonna do, at the end of class, I wanna be able to separate them out again, right? So the next team can use them. All right, so I'm gonna give you yours, and I'll give you guys about 3 minutes to organize, and then you can start asking.
No,
There you go.
that's not.
The shapes won't make any difference right now,
Yeah, that's not black. Years.
because the other shape that matches is gonna be on the other side.
Yes, okay, so we're gonna get, I think we can get pressure and gasket, they're like the same sort of thing.
Evaporation.
Evaporation.
There you go, I'll give you about 2-3 minutes to organize.
I'll put it like
Okay, come on, we gotta hurry, elements can go over things.
So
Element chemistry.
Okay.
Here, let me see. One or two set of characters you start.
No change.
From liquid to solid. Boiling also with boiling cooling.
Has definitely.
Carly, if you want these, I will do these all physical change.
We're solid. No, definitely, that's, different.
Hey,
You got another minute to organize. Nothing is gonna match over here. They have the ones that are gonna match. Nothing's gonna match.
These are together, these are the same.
One of them drops.
Particles, anyone got anything on particles?
That's just.
Okay, particles. Yeah, we're organizing them by word.
Particle, this whole particle, change, all the changes you go to.
Yeah.
I mean, a lot of my change, that, wait, what change?
The change. Oh, yeah, because it's solid, liquid, and solid.
Okay, so listen one more time. Let's make sure we understand how it's gonna work. All right, if your team, I'll let you boys go first. So what you're gonna do is you're gonna either ask them, you're gonna either give them a term or a definition. And then they have 15 seconds to find its match. And you'll know if it's right because they will fit together like a puzzle, okay? And then if they get it right, they get to keep that set, but we wanna make sure that we keep them pointed the right direction. Don't tell them to move your buttons.
Yeah.
No, make sure you have it.
No, this one.
No.
Particles would be like.
And I'm gonna switch it right here. Everybody understand? Alright, so, are you ready?
No.
Wait, can I sit?
Okay, hold on. Alright, so organize. Alright, you ready? So I'm gonna let you ask. They have then I will start the timer. They have 15 seconds to find the answer. Okay? Ready? Ask your question, Eunice.
Amorphous solid.
Okay, 15 seconds. Can you
I
find
did
it?
not do that.
Amorphous solid. Amorphous solid. Look at your, so it's gonna be one of the long ones. So can you find it? Amorphous solid. And stop.
I could
No,
not.
it's not it.
I've never heard of that.
No.
No, that's not it. Okay, so you get to put it back down. All right, now, you guys get to ask.
Okay, you're going to go with Okay, yeah. Just do any of them.
Yeah.
Viscosity.
Viscosity,
What?
go.
Exactly.
You have 15 seconds to find it.
Changes.
Viscosity.
10,
9.
8.
Okay, that's your answer?
No. No, this one, this one, this one, this one.
Okay, that one. No.
Ah, Lewis got it. Lewis got
I'm telling you.
it. Lewis got it. There you go. All right. So that means, so wait a minute, you had the definition, right?
Yes.
So all we're gonna do is, you get this one, but we're gonna place it this way, so that when I sort them, I know this goes back to them. And this goes back to this side. All right, are we ready? All right, you guys get to ask.
Whoa.
Ready?
How do you get
Ask. What is it?
directly proportional?
Directly proportional.
Can I do the thing? Can I see the thing?
Go to directly proportional.
Directly proportional. It's a straight line, it's a straight line.
This one.
No, what? I don't want it. It's not. It's not that one.
It is.
Very good. So you get to keep this one. So you have this. You had this. Excellent. Okay. You guys get to ask. Are you ready? Ask.
Electrolysis.
Electrolysis
Electrolysis.
or electrolysis.
This one.
Okay.
Yeah.
Boom, they got it. So which did you have? That's the way. Very good. All right. You ready to ask?
Yo,
Wait, No, it is.
should we do this?
You guys just hurry up, pick.
Okay. Yeah.
What is it?
Do the same one.
Amorphous solid again. Good.
Wait, I think I know what it is.
It's not that thicker one.
Is it this one?
10.
It's this one, it's this one, it's this one, it's this one, it's this one.
This one.
Yes, very good. All right, so you gonna get it goes this way.
Yes.
All right, are you guys ready?
Yes.
Okay, what you gonna ask?
Let me see it.
These are the difficult one.
Maybe up to. I need to see it. Up to or more. Oh, more.
Maybe
substances?
2 or more substances which are not chemically combined.
Mixture.
Oh.
It's not a mixture.
There you go. All right, so ready. So that's gonna go.
It doesn't look exact.
So wait, they have it this way, right? This way.
Actually,
All right,
next
ready?
one I'm gonna look for is.
No. Wait, is it ours?
It's their turn to ask.
Okay.
Ready? Set, ask.
Wait, no, did we get
Oh.
that? I just.
Oh, you said, sorry, your turn to ask. I take it back.
No, that's too medium shape.
Ask you first.
Okay. This is easy. Change alters the form or appearance of the use of a
Physical
symbol.
change, physical change.
Ooh, they got it right away. Okay,
I
here you go.
didn't do the shape, I did.
That one's good. Ready? You had, yes, this way, right? Okay, who's next? Don't stop too much, my other chance. Okay, ready?
No. That's sweet. I wanna say. No, oh my goodness. Here.
What is it? Read it, read it.
Describe the relationship between the pressure and volume of gas.
Okay, pressure and volume.
I did.
I can't see it.
Oh, wait.
Pressure.
Wait, no. It's all.
You got it. Nice job. All right, so that's on your side. This is on this side. All right, you guys have one? Wait, let me choose. He hasn't chosen. Pick one even. What's the hard one? Ready? Okay, read it.
Phase change from solid to gas without first becoming a liquid.
Ooh.
Put it down, put it down.
Put it down.
Yep.
Ah, boom, there you go, sublimation. You had sublimation, yes, okay. Y'all ready?
Okay. Electrodes.
Electrodes, go.
No.
That usually kind of
No,
like
no,
that.
no. Wait, no. Yeah.
There you go. all right, you got that one, so that goes that way, yes, just like that.
Second machine.
All right, do you have one that you wanna do?
No way, bro. That's like so easy. Just don't show them the side.
Okay. Ready?
No, let's see.
See,
You have to show, put it
okay,
down.
ready, and, okay,
Inversely
inversely proportional, go.
Inversely proportional.
That's like the old.
It's not that, 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 it's not that.
Seven, six.
I see it.
Wait, that would look.
I see that as well. I see it as well.
Just do it.
That's fine, that's fine. No.
Yeah.
The next time. Okay, y'all ready for your next one?
Yup.
Okay, it's gonna be,
Okay, next one.
yeah, the last one, they can get
Very difficult, we're gonna hit
a
the.
tiebreaker
We're gonna
maybe.
hit the.
Oh, no, you can tie it up. No, you can't, it's their turn. All right, right.
Hit the combination of symbols that shows the ratio of elements of the compound.
Okay, throw it down, throw it all the way down.
Combination of symbols.
Very good. All right, so now I'm gonna give you back your Ziploc bags and you need to be sure, let's see, okay, this goes to you. This goes to you, yes, you did, this, and then these go. This, 1, 2, 3, 4.
That one there.
Ah, yeah, there we go. All right, I give you bags and you can throw them back in the bag.
I think everyone except the one that we wanted.
Ah, yeah, there you go. Great, here you go. Put them all back in. Good job. Very good, very good. And you can get ready for lab.
I wanted on this. Okay, so yeah, guys, yeah.